Okay, so now we're going to discuss some word problems involving fractions, and we are going to use our teacher solution method that we discussed in the previous clip where we introduced the model drawing process. So these problems that we're going to talk about in this clip I have taken directly from the Singapore textbooks. So the first two problems we are going to do are from a 4th grade text, and the next problem, two problems after that, are from a 5th grade text. So first problem we're going to look at is as follows. Mr. Johnson bought a can of paint. He used half of it to paint a table and 1/8 of it to paint a chair. How much paint did he use altogether? Now, as we discussed in our original discussion of model drawing, the model drawings are used to serve as a bridge for students that have a hard time reading the words of a problem and deciphering the correct arithmetic that is needed to solve the problem. Hopefully, our students will just be able to read this problem and see that the addition of 1/2 plus 1/8 is the arithmetic necessary to solve the problem. However, if there are students that aren't able to make this connection, then hopefully a diagram can make that arithmetical a little easier to see. So, we start, as we start all of our problems, by simply drawing a bar. And this bar represents Mr. Johnson's can of paint. In the second sentence of this problem, it reads he used half of it to paint a table. So all we need to do is represent the fraction 1/2, and we all know how to do that at this point. We simply cut our entire bar into 2 equal pieces, and perhaps we shade one of those pieces to represent 1/2. We are also told that Mr. Johnson used 1/8 of the can to paint a chair. So now we have to somehow illustrate 1/8 of the entire can. What that means is we need to represent the fraction 1/8. That means we need 8 fractional units. So we need to split the whole into 8 total units. It's already in 2 units, so now we need to split each of these 2 units into 4 additional units, so we'll get 8 total units. And I just realized that I need to adjust my bar to make it look reasonable, that the shaded part is a half. Much better now. Okay, so again, we need 8 total units, so we might split in half twice. Notice that in doing so, the 1/2 of the can of paint that he used to paint the table has now been renamed as the fraction 4/8, right? Because now there are 8 total pieces, so the fractional unit is 8, and our denominator is going to be 8. 4 of those units are shaded, so the 1/2 is renamed as 4/8. And we now need to somehow represent the fact that we used 1/8 of the can to paint the chair, so I can maybe shade that a little bit differently. And the question reads, how much paint did he use altogether? Well, that's going to be all of the shaded stuff combined, right? The first shading represented how much he used to paint the table. The second shading represented how much he used to paint the chair. The question mark, as we always include in our problems, is simply what has been shaded, because that represents what he painted. And now, just like the addition problems that we saw with whole numbers, there's no need for a unit sentence or a very complicated explanation because the diagram itself explains the correct arithmetic, right? In fact, we don't even need to really illustrate the arithmetic. We could see that really 4/8 plus 1/8 is the arithmetic that's necessary, but really we can just look at the fraction of the entire bar that's shaded to see 5/8. As teachers, we would want to point out that the correct arithmetic that was needed here is 4/8 plus 1/8. To give us our 5/8, because again, we are hoping that our students develop enough facility with arithmetic models and just knowledge about arithmetic that the bar won't be necessary eventually, that they'll be able to just read the problem and figure out the correct arithmetic needed to solve the problem. Okay, our next problem is a fraction multiplication problem, again found from a 4th grade Singapore text. 48 children went to the zoo. 3/8 of them were girls. The question asks how many boys went to the zoo. Now, hopefully, again, students will be able to just read the problem and figure out the correct arithmetic needed to solve the problem without having to resort to drawing bars. We have one kind of preliminary step here in that if 3/8 of the children are girls, then we have to figure out what fraction of the children are boys. 5/8 of the children will be boys. And then, hopefully, if 5/8 of the children are boys, and there are 48 children total, hopefully students will be able to figure out just from the problem that the correct arithmetic is 48 multiplied by 5/8. But again, not all students are going to be able to do this. The main reason students struggle with word problems is that they have a hard time going from the words of the problem to the arithmetic necessary to solve the problem. So To bridge that gap, we draw bar diagrams. So in this case, we're again going to just draw a bar, and the bar that we draw represents the whole unit, which in this case is the 48 children that are going to the zoo. We're told that 3/8 of these children are girls, so we need to represent the fraction 3/8, and we all know how to do that at this point. We need to split the bar into 8 pieces and shade 3 of them. An easy way to split into 8 pieces is just to divide in half, and then divide in half, and then divide in half again. And then since 3/8 of them are girls, we're going to shade 3 of those pieces, so the fraction 3/8 is represented here. But there's a slight trick to this problem in that we're actually not interested in the shaded pieces, we're interested in the unshaded pieces. This is a part-whole type of problem in that we know what the whole is, we know what one part is, we need to figure out the other part. So the number of boys is actually the unshaded portion of the diagram, which is in this case 5 pieces. Now, this is a problem where, again, the arithmetic is not as obvious as it was in the fraction addition problem, so these are the types of problems we are going to use unit sentences to solve. Okay, so that is the second step of the so-called teacher solution we use to solve word problems with model drawing. We need a unit sentence. Now, the nice thing about fraction problems is by the very nature of a fraction, every piece in this diagram is a unit because every piece is exactly the same size. So the unit sentences in these fraction problems are actually quite easy to figure out and quite easy to interpret. It's very clear that 1, 2, 3, 4, 5, 6, 7, 8 units makes the whole, but 8 units is equivalent to 48. So that's our unit sentence. 8 units is equal to 48. If we look at our diagram, then the question mark is bracketing 5 units. So we're eventually going to be interested in 5 units. Now the way that we can go from 8 units to 5 units is first to go down to 1 unit to figure out what 1 unit is equivalent to. But again, our knowledge of partitive division tells us if we know that 8 of something is 48, then one of those things is 48 divided by 8. So if 8 units is 48, then 1 unit is 48 divided by 8, which is 6. And then, of course, we are interested in 5 units. We know that if 1 unit is 6, then 5 units is 5 times 6, which is 30. And as we always do, we would write a complete sentence answer. 30 boys went to the zoo. Notice again what came out of our model drawing process and our unit sentence process is we started with 48, divided by 8, and multiplied by 5. And that's the arithmetic that we noticed should have been necessary at the beginning. Take 48, multiply by 5/8. Dividing by 8 and multiplying by 5 is equivalent to multiplying by 5/8. Okay, so now we move on to a couple of problems I took out of a 5th grade Singapore text. The first problem reads, Sarah poured 2/5 of a pint of fruit juice equally into 4 cups. How much fruit juice was there in each cup? Okay, so really we have 2/5 of a pint that we're dividing evenly among 4 people. Again, our hope is that students can read this problem and they can conclude that the correct arithmetic is 2/5 divided by 4. And oftentimes if students struggle with a problem that involves fractions, it's because oftentimes they have a mental block and they just think they can't solve anything that involves fractions. So one way to gain some insight into what the correct arithmetic is needed to solve this problem is just ask your students, what if this 2/5 of a pint was a nice whole number like 12? And if you rewrote this problem as Sarah poured 12 pints of fruit juice into equally into 4 cups, then it would be obvious what the correct arithmetic is, right? It would be obvious that the correct arithmetic would be 12 divided by 4 in that case. So that can help you kind of break down the mental block that many students have when it comes to fraction problems. The interpretations are the same. The problems are going to be solved in the same way regardless of whether this is 2/5 of a pint or 12 pints. It's still going to be division. Again, we hope that students can figure that out without drawing bars. But if they can't, then again, the model drawing process will hopefully help them figure out the correct arithmetic and help them solve the problem. So in this case, 2/5 of a pint of fruit juice is poured equally into 4 cups. So this is partitive division. 2/5 of a pint of fruit juice is our total amount of fruit juice in this case, and we're pouring that into 4 cups equally. And the question asks how much fruit juice was in each cup. Each of these parts of my diagram represents 1 cup, so we put a question mark in one of them. Again, at this stage, hopefully students recognize this as, again, being partitive division for 2/5 divided by 4. But again, if they can't, we're going to carry out the unit sentence process to solve the problem anyway. Again, at this stage, we do want to interpret the diagram in the form of a unit sentence. Quite clear, again, in this case, that 1, 2, 3, 4 units is the total. 4 units is also equivalent to 2/5 of a pint. So 4 units equals 2/5. If you want to write 2/5 of a pint there, that's fine. Oops, plural. Again, our knowledge of particle division tells us that if 4 units is equal to 2/5, then 1 unit is going to be 2/5 divided by 4. Now, our knowledge of fraction division tells us that 2/5 divided by 4 is equivalent to 2/5 times 1/4. And that's actually clear from the diagram as well. It's clear that 1/4 of 2/5 is what is represented by this question mark. Well, fraction multiplication tells us that 2/5 times 1/4 is the same as 2/20, and in lowest terms, 1/10. And that's actually our answer, right? Because we're actually just interested in 1 unit. 1 unit is 1/10, so our complete sentence answer we would write out is there was 1/10 of a pint of fruit juice in each cup.